Hi, this is Mr. Ward, and I'm going to do a video key for number 13.2, do now 13.2 for today. I know most of you have probably already taken care of this, but just in case, I needed to make sure I caught a few people who didn't get to the do now yesterday. So please do make sure you have bookmarked the levels data sheet. Later this week, I'll be adding the linear levels into there as I work towards and updating things, of course, for the report cards. So linear or not. So it is certainly a line, but linear equations have a constant rate of change. So this is not linear. This has a changing rate of change in terms of y change versus x change. So the rate of change of this thing is steeply negative, then somewhat negative, then zero, and then starting to be slightly positive, more positive, and much more positive. Not as positive as it was negative here, but that is not linear. To be linear, one has to have a constant rate of repeated addition or repeated subtraction change going on. Okay, so is this linear or not? Yes, it has a straight line. I'm not trying to trick you at all. In fact, I'm never really trying to trick you, even if it feels like I am. I'm not. Or what the heck are those things called? Why the heck are those things be called y-intercept and x-intercept? Well, it's actually a fairly capped and obvious thing. The y-intercept is the place where any kind of function or line goes through the y-axis. It is the place where x is 0 and y is some value. The x-intercept is a place on a graph where the graph goes through the x-axis. And that the x-axis is defined as all places where y is 0. And so wherever the x-intercept is, y is 0 and x is some value. And both of these are going to be extremely important for us as concepts, the y-intercept and the x-intercept. We'll focus a little bit more on the y-intercept in the linear functions unit, and then when we get into polynomials, we'll be focusing a lot more on the x-intercepts. But both are extremely important. We often give the y-intercept the letter B as a designation and the x-intercept the letter A as a designation. But the big idea is that the y-intercept is the place on the function where x is 0, because the y-axis is defined as all points where x equals 0. And the x-intercept is a place on the x-axis where the line intersects or is intercepted. And it's, of course, a place where y equals 0, because all places on the x-axis, y equals 0. So that the simple way of thinking of it is, of course, that the y-intercept is where the line goes to the y-axis, and the x-intercept is where the line goes through the x-axis. But it is really important to keep in mind this idea of 0, because that's going to be how you're going to find it. You're going to find that y-intercept by knowing that x is 0 and then solving for y. You'll find that x-intercept by knowing that y has to be 0 and then solving for y. So the intercepts are called that because they are where the line or function crosses or is intercepted, if you like football analogies, by the x or y axis. Okay? But that concept of 0 is really important. Linear or not? Okay, so when I look at this, my first thing is to check the x's. Do they go up by a regular interval? Okay, they do, then it's very simple to check the y's. So then I'm going to check the y's. Because the x's are all going up by 1s, it's the y change is a simple thing to check. So the y goes from 10 to 7, that's -3. 7 to 4, that's a -3 again, and 4 to 1, that's another -3. If it's hard for you to see this, you might want to organize these into an XY table, then you might be able to see it better vertically. But yes, this, as x increases by 1, the y value changes by repeatedly subtracting 3. So there's a y equals -3x involved in this function, and it is linear. It has a regular rate of subtractive change. linear or not. This one's in a table. Oh, look, I just reversed the numbers. So -5, -4, -3, -2. And instead of going 10, 7, 4, 1, I went 1, 4, 7, 10. So in this case, we're adding 3 each time while x is going up by 1. So yes, of course, it is linear. Okay, just a reminder, grades closed on Friday, but I can still accept some stuff if you haven't gotten it to me. Wednesday is kind of my practical deadline. If you're going to need longer than Wednesday, it's really important for you to communicate. And in general, it's important for you to communicate. So I don't have to sift through the mountain of data to find, it's just in your interest to make sure I know what you have completed. And I would really like to be able to upgrade if I can. All right, I'm going to stop, and I hope that